Okay, so we should be recording. I had some problems with my smartboard in class today, actually all day long, really. So I'm kind of just doing my own video with no kids in class. So it'll be a quick video, which is probably better for everybody anyway. So we did absolute value in the last class. If you missed that lesson, that one is recorded. It should be posted by the time you see this one. But a quick review of absolute value is that absolute value and the symbol for absolute value are these big thick lines around a number. So for example, if I say the absolute value of 3, that means how far away from 0 is 3. So if I have a number line, and there's 0, well, 1, 2, 3, 4, so there's 3. Well, the number 3, the positive number 3, so right here, is 3 spaces from 0, or 3 units from 0. Or you could think of it as this: the length of the line segment from 0 to 3 is 3 units long. So therefore, the absolute value of 3 is 3. That's how far away from 0 3 is. It's 3 units away. Now, here's where the tricky part comes in. The absolute value of a negative number, so now let's say I have -3, but I want to take the absolute value of -3. Well, -3 is right there. How far away is -3 from 0? Well, -3 is also 3 units from 0. That's how long that line segment is. It's 3 units long. So the absolute value of -3 is also 3. So what absolute value is really measuring is the distance from 0. How long, how far away, what is the length, whatever you want to call it, from the number in the brackets, whether it's in this case 3 or -3, how far away is that number from 0? So if you're not grasping that concept, I said you'll be able to get by when it comes to my quizzes, maybe even on the district and state quizzes. But the real concept of absolute value is distance from 0. Now, here's all you have to know how to do to solve for absolute value. So you can, if you need to, I'm going to get rid of that. If you need to go back, rewind and pause, you can rewind and pause it if you're behind. So if I have that equation, so we'll have to leave it there. If I have this equation and I want to solve for x, what this is really saying is I need the distance. So again, these lines right here are saying I need the distance from 0 to equal 12, because that's what I have over here. So these lines are measuring the distance from 0. The absolute value is the distance from 0. So I want a distance from 0 of 12. Well, one number, I'm just going to do a super fast graph. If I count from 0, one number that is 12 away from 0 is positive 12. So that means these brackets could have the number positive 12 in it. So that could be one number that makes the right side equal the left side. But there's also another number, which is negative 12, that is also 12 away from 0. So I could also have negative 12 inside these brackets, and that would still be a distance from 0 of 12, which is what we want right here. We want to be 12 away from 0. So I have to really solve this equation twice. I have to solve it once as if my equation was set up like this. 3 subtract 5x equals 12. Because we said positive 12 is 12 units from 0. So I'm going to solve this out. It's just a normal two-step equation. We said we always want to get x alone, which means we need to get rid of those two things. Now that we know which two things to get rid of, we have to figure out which one we get rid of first. And we said we always start farther from 0. I'm sorry, farther from the variable. Or we also said save the variable term for last. Either way, you should be starting with the 3. So I know I want to start with the 3. Now I just think about, well, how do I get rid of that 3 if that's where I'm going to start? Well, I do the opposite. The opposite of having a positive 3 is subtract 3. Well, then my number 1 rule is whatever I do on one side, I do on the other side. So I get a 9. You have got to remember this negative sign in front of the 5 is glued to that 5. You also have to make sure you bring the x down with it. Now I just say, okay, well, what does negative 5x mean? Well, that means negative 5 times x. Negative 5 multiplied times x. Well, I need to do the opposite. Remember, we're always doing the opposite math to try to get the variable by itself. Well, the opposite of multiplying by negative 5 is to divide by negative 5. Well, if I do it on one side, I do it on the other side. So my final answer, my first answer, I should say, is x equals negative 9/5. Now, here's the thing. That is not the only answer for an absolute value problem. Because remember, we also said negative 12 is 12 units away from 0 as well. So what I now need to do, and I'm going to do this one in a smaller space, I need to create a new equation. I'm going to erase a little bit of this. I need to create a new equation, but this time I'm going to set it equal to negative 12. Because we said if negative 12 was in those brackets, it is also 12 away from 0. So negative 12 in these brackets actually equals 12 because it's telling you the distance is 12, which would mean this right side in here in the brackets would equal the left side, which is 12. If you're not following all of that, just remember you do a separate equation and you just change the number to a negative number on this side of the equation. So instead of positive 12, I'm just making it negative 12. If you're not following what the distance away from 0 means. You can also look up other videos on absolute value if you're not understanding the concept. My steps are still going to be the same. I still want to get x alone. I still need to get rid of the 3 and the negative 5. I still start farther away from the variable. Whatever I do on one side, I do on the other side. That's negative 15. That's negative 5x. My last step is division. So my answer is x, in this case, is positive 3. Negative 15 divided by negative 5 is positive 3. So when it comes to your solution for this problem, there's actually 2 possible solutions. You would say x equals 3 or x equals negative 9/5. So that's how you solve an absolute value equation. You have to actually solve out 2 equations, and in one of them, you make the answer negative. All right, so the next thing we did in class was we did, and I'm going to do it a little differently than I did in class. So if you are watching this again, then it might not look the same. We didn't talk about this in class, but I'm going to talk about it. When you go on a trip and you look up something and it's like, you know, telling you how far you're going to go or how much time it's going to get there, there's a formula for distance. And the formula is distance equals the amount of time you travel times the speed you travel. So if you drive 60 miles an hour and you drive for 3 hours, you would say 60 times 3. So again, distance would be, so if I'm going for 3 hours, I would multiply that by 60 miles per hour, and my distance would be 180 miles. Here's the thing though, we don't normally care about distance. And a lot of this is before Google, but we normally care how long it's going to take us to get somewhere. So we don't really care about this formula normally. We don't really want to calculate the distance. A lot of times we want to calculate how long it's going to take us to get there. So we're getting into a new concept called literal equations. And what it means is we're going to rearrange everything in this formula, and we want to get time to be all by itself. We want to know, well, what would the formula for time be? If this is the formula for distance, how can we rearrange that and make the formula for time from that? Well, it's just like we would solve any equation. If I want to solve for this variable, we can think of that as a variable. If I have multiplication right here in the problem, I just need to do the opposite of that, which would be divide, and I want to divide by speed because I want to get rid of speed. And if you're not understanding this, don't worry about it too much. Well, again, whatever I do on one side, I need to do it on the other side. So I would divide this side by speed. So the formula for time, if you want to know how much time it's going to take you to get somewhere, the formula is just, and I'm going to move it a little bit. Why my board is doing just messed up today. So the formula for time then is the distance, how far you're going, divided by how fast you're going. That will give you the time it's going to take you. So that's how we can kind of change around the original formula and solve for something else we want to know. That's called a literal equation, or I think in the book they're calling it solving for a variable when you have letters as coefficients, something like that. So now let's get into more what you're going to see regarding different types of problems on quizzes and on your district stuff. So if I have this particular equation on the left, I want you to try to solve the equation on the left. I mean, you should all be able to solve the equation on the left. So pause it, solve it. I'm going to go ahead and move forward. Again, I want to get m by itself. I start then by moving, I get rid of the number farther away from the m, which is the 7, by doing the opposite. Whatever I do on one side, I do on the other. Bring down the 2m, divide, divide, and there is my answer. M equals 9. Now, if I look over here on the right, I've got two really weird looking things. A lot of you are gonna freak out when I say solve for m. So I'm looking right here. Solve for m. A lot of you are gonna freak out when you see this. It's the same exact problem. We have the variable we're solving for right here. Well, it was right here in this problem. I'm multiplying that times some number. Now, I may not know what k is, but it's still an unknown number, so I'm still multiplying m times some number. Just like over here on the left, I was multiplying m by the number 2. So I was saying 2 times m over here. And then after I multiply those together, I'm subtracting some number here, 7. Well, over here, I'm also subtracting some number. I just don't know what that number is. So it's really the same exact problem. I just don't have any numbers. I have all variables. We do not change anything at all as far as the steps go. We're going to do the same exact steps in the same exact order. It's just we don't get a final answer. Like our final answer is not, I mean, we do get a final answer, but our final answer isn't going to be a number. It's going to be a bunch of variables. So I'll show you what I mean. So again, if I'm solving for m, that's the variable that I consider to be my variable. I now need to get rid of the k, and I need to get rid of the subtract h. The way I do that is just like I do in the other problems. I start with the one that's farthest away from the variable m. Well, h is farther away. So I do the opposite. I do plus h. Well, that's the same exact thing I did over here. I said plus 7. So then I have to do the same exact thing on this side. And this is where the difference comes in. In this problem over here on the right, this one right here, I can add 11 plus 7 and get 18. I'm sorry, that was the problem on the left. I said right. In the problem on the right, so now I'm talking about this problem. I cannot add 11 and h. They're not like terms. They don't have the same variable. They don't have the same letter. 11 doesn't have a variable at all, and then h is just a variable. I can't combine those. So I can't get just one number or one term. So what winds up happening is I just say, well, all I can really say for this is that's just that right side is just 11 plus whatever h is. That's all I can do. I can't combine them into one term. We'll solve that one separately in a minute. So now I still bring down this k times m. I didn't do anything with that, so I'm still bringing that down. So the left side, I have k times m. The right side, I have 11 plus h. Well, just like bringing the 2 times m down over here. Just like on the left, where I have 2 times m and I divided, and then I divided here, I'm going to do the same thing. If I want to get rid of k times m, the opposite is to divide by k. That'll give me just m all by itself. Well, if I do that on one side, I got to do it on the other side. I got to divide by k over there. Again, I can't combine anything on the right side into one term. I can't combine the 11 and the h, or the h and the k, or the 11 and the k. So my final answer is just this. That's all I can do. It was the same steps. I did the same exact steps. It's just my final answer looks a little bit weird. I'm going to do one more example here from the one that I just kind of drug out of the way. Now I'm going to do this solve for j problem. I'm going to do it pretty quickly. So again, j is the value that I want to solve for. Well, the farthest variable is w, so I need to get rid of that first. That's positive w, which it is. I subtract w. Well, I subtract w there. I subtract w there. Well, I can't do anything with s subtract w. There's not one term I can create. So I just bring that down as s subtract w. I need to make sure I bring the negative sign down with the q and the j. That's q times j. Well, if I want to get rid of q, I divide by negative q. Well, that means I divide by negative q over here. Now, there's one little tricky bit for a final answer. You would not normally see a negative number in the denominator. They would kind of flip all the symbols around. And your real final answer, I'm just going to write it really small. It would be S would become negative, W would become positive because you're flipping every single symbol. So W subtract S and then divided by positive Q. I don't care how you leave it for my quiz, but just to let you know, they're normally going to flip the sign of everything because they don't want to have a negative in the bottom. I'm not going to explain why you flip the sign. You can look that up if you really want to. All right, so I'm going to do a quick problem from the book pages. I think I still have them up. Maybe not. Oh, I had them up a second ago. Let's see. Time down. I'll go into it super fast. It's going to take long. Hill, if you haven't ever gone in the online book, this is how you get into it. It has all the pages, the actual pages from the book, just like they look in the book. It's also got an interactive version. I'm going to just go into the book pages exactly like they look. So interactive version looks much different. That's the one I use in class. So if you watch other videos, when you see me use the online book, it's that. This though is what I want to show you. So it's telling me to solve for different variables. I'm going to come way down to the bottom and I'm going to solve Actually, none of the ones really, until I get to fractions at least, are that difficult. I'm not super worried about these with fractions. If you want to try them on your own, that's fine. I'm not worried about them. You will need to know how to do them in Algebra 1, but not as much. I mean, you actually, in Algebra 1A, you should know how to do them, but we don't have time to cover every single type of problem. So let's look at what's the one I think is the most difficult. Oh, let's look at number 10. 10's got the variable c on both sides, and they want us to solve for c. There we go. I'm going to rewrite it. So negative 5c plus d equals 2c. So in order to get, like, to solve for c, I have to have all the variables on one side. Now, I could do that one of two ways. I could get rid of them on the right, because remember, I can't just say 2c plus, I can't just say, well, I'm just going to add 2c over here. Can't do that, because remember, my number one rule is whatever I do on one side, I then have to do this on the other side, and that doesn't get rid of anything. I still have variables on both sides, so I cannot do that. So that's the first thing you need to understand, is you cannot do that. I have to think about getting rid of them on one of the sides. I could subtract 2c here and then subtract 2c here, but then that kind of confuses people sometimes, because they're like, wait a minute, where did the variables go? On the right, they're gone. I don't have anything there. Technically, you still have the number 0, so you could put a 0 over there. I'm going to start, though, by getting rid of them on the left, because then I'll still have this variable d, and I'll have all my c variables to the right. So I would say plus 5c. Well, whatever I do on one side, I'm going to do on the other side. So I get d equals 7 times c. Well, if I want to solve and get c all by itself, this is 7 times c equals d. So I need to divide by the 7 to get rid of it. Well, then I need to divide by 7 here. So my final answer is c equals d divided by 7. So I think most of the first few problems, I believe, are more similar to the other two problems I just did a second ago. Sometimes kids get confused by something like number 6. Well, that's really just one step. If I want to get p all by itself, I want to get that variable all by itself, I just need to get rid of w, and then I'm done. So I need to do the opposite math. If that is w times p, I can write it really small right here. Well, if I want to get rid of w, I do the opposite. I divide by w, and then I need to divide by w over here. So my final answer, so that goes away, I just get p equals r divided by w. So you can practice all of those. Talk to me in class if you have questions. I think I did one of the more difficult ones for you right there. I'll get this, hopefully, well, it's already posted if you're watching.